Alright guys, last section, last part 3, 51 through 75. To prove a rhombus, we need 4 congruent sides, but not congruent diagonals. Alright, cool. I'll kind of summarize those 4, in case you missed those. Let's move on to 52. So we have a parallelogram here, so angle A is 99. So all we have to do really is remember opposite angles are congruent, so this is also 99. And then consecutive angles add to 180, so this would have to be 81, 81. And just fill it in. Here we have AB is x plus 24 and 4x plus 15. And then RK is 3y minus 11, and this is y plus 40. Okay, so our dilemma here is that we are going to effectively have to set opposite sides equal, and what we don't like about that is that we have an x and a y, and we have an x and a y. So we're going to have to do what's called a system of equations. So this won't be on your test, so I'm going to just quickly show you the results and walk you through it. So we write the two equations, so those are the opposite sides, so 4x plus 15, y plus 40. Then x plus 24 and 3y. And we're going to take one of the equations and we're going to solve it for x. And that's what I did here. I subtracted 24 and I got x equals 3y minus 35. So I'm going to take this piece, I'm going to plug it into the x over here. That's called substitution. So you can see that x is no longer there, and I plugged in what x equals from this equation over here. We distributed the 4, combined like terms, and took it all the way down, and we solved that. 11 goes into 165 15 times. Okay? Then we're going to take 15, plug it in for y, and we get 3 times 15 minus 35, and we get 45 minus 35 equals 10. Again, going a little faster through that because we are not going to see a system of equations problem like this on this final. But you would set equal to each other the opposite sides because that's true of a parallelogram. Alright, number 54, we have K is in the middle, so it's going to be somewhere around here. Goes to R and G, so it's going to be 49. This is going to be around G going to A to R, that's 82. And then we're trying to solve for RGK, which is this angle right there. And we're trying to solve for ABG, which is right here. Now, really easy to solve for this piece because they're a linear pair, so that's going to be 98. And then I want to find this guy, which we can't find exactly right away, but I can find this angle here because these three are a triangle, and so we could add them up and subtract from 180. So adding these two, subtracting from 180, I left over with 33 degrees. And then remember, we have parallel lines because opposite sides are parallel. So if this is 33, this is also 33 by alternate interior angles. So we get 98 and 33. Then we get AG is 4x plus 7, and KG is 2x plus 33. And we're going to set those equal to each other because diagonals are bisected. Diagonals aren't congruent, so I can't set this equal to this, but those I can set equal to each other. And so that one's a really quick problem to solve. Subtract 2x, add the 7, divide by 2, and we get x equals 20. If I did that correctly. I think so. Oh, no, I apologize. We subtract 7. So that's good. I apologize. Yeah, double check that. So that's 26. Divide that by 2, I should get 13. Whew. There we go. I was like, I'm feeling like that's not quite right. Sometimes you get ahead of yourself on the test, so you gotta back it up a bit. Okay, let's move on to 56. Okay, so 56, 57, and 58 are pretty long problems here. So let's go ahead and just show you the quick way or quick answers to these because you won't have to do this quite on the test. Okay, so whoa, lots of stuff here. So determine the quadrilateral of the parallelogram using distance formula. So I just kind of powered through this here, but we found the distance of the opposite sides were square root 50, square root 50, which is good. And the other two sides were square root 104 and square root 104. So that means yes. If my opposite sides are congruent, we're good. Same thing we can do with slopes. So I found the slopes of the opposite sides were 1/2 and 1/2, which is good. But then when we got to the next set, we got 8 over 7 and 7 over 5. Close, but not. So this is not. These are not parallel. Same slope have parallel opposite sides, so that one was a no-go. And then here we just had to show one pair of congruent sides. So I was only looking at CD and BE here. Their opposite sides were congruent, and their opposite sides did have the same slope, which means the same pair of opposite sides were congruent and parallel, which we can prove our parallelogram, or quadrilateral, is a parallelogram. All right, so all of these guys right here are going to be focused on knowing the rule. 2 to the right is adding 2 to the x, so that's going to be 3. And 6 up, we're going to go add 6 to that, so that's 3 comma 3. Rotate 180, our rule for 180 is just to change the sign of the x and the y. So that's going to become -3 comma +1. Counterclockwise, remember that's a positive rotation of 90. So a counterclockwise rule is -yx, so we're going to flip them. So I like to flip them first. And then the front one, I'm going to change the sign. So -4 comma -2. Reflect over the y-axis, we actually also have a rule for this, which is -x comma y. So we're just going to take this point. We don't flip anything, we just change the x to a different sign. In this case, it's going to be negative. Reflect over the x-axis also has a rule, which we just change the y value. So it's -5, and this is going to become this opposite sign. So -5, -4. Y equals x, we just simply switch the y and the x values. So this should become -2 comma 3. And then y equals x, we switch them by also changing the sign. So we get actually +4 comma 2. Okay, so just a lot of rule following on that. And then we get to the back, and it's factor time. All right, so to factor, we go ahead and set up the x factoring for the first 3, 12 and 7. What two numbers multiply to 12 and add to 7? That is going to be 3 and 4. If you don't know, write out your factor list. So I'll do it for this one, but I'm not going to do it for the other one. So 1 times 2, 2 times 6, 3 times 4. So write them out and say which ones would add or subtract to 7. 3 and 4 works. We just get x plus 3 and x plus 4. There we go. Next one, again, -9 and -8. That's going to be a +1 and -9. So x plus 1, x minus 9. Those multiply -9 but add to -8. And then here we got -30 and a +1. We want two numbers that are very close to each other. So that would be 6 times a -5. So x plus 6 and x minus 5. The next two, we want to GCF first. So we're going to take the GCF. So we're going to take a 5 out of all of these. And we're left with x squared minus 5x plus 6. So we can then factor that. I'm just going to put a 5 over here, because we're going to do the same thing, but there will be a 5 sitting out in front. So we have 6, -5. The two numbers that are going to do that would be a -2 times -3. So you get x minus 2 and x minus 3. Here we can factor a 2 out of everything, and we get x squared minus 8x minus 20. And again, I'm going to leave the 2 there. -20 and -8 is going to be at -10 times 2. And so we get x minus 10 and x plus 2. So the next three are definitely the most challenging. You might even need more work, or might need more area to show your work. Sorry, I'm walking away from the camera to get an extra sheet of paper. So for this one, we can't factor the 2 out of all of these. So what we're going to do is we're going to actually do what's called split the middle term. And to do that, we have to actually multiply 2 times 18. 2 times 18 is going to give us 36, and then we're going to put -15 on the bottom. So the two numbers that would do that would be -3 and -12. And then here we can split that middle term. So we get 2x squared minus 3x minus 12x plus 18. So again, these two values just came from negative 15, what we did over here. And then what we want to do is we want to do factor by grouping. So we'll just boop, 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 and look for the thing that we can pull out. In this case, we can pull out an x, so we get 2x minus 3. Now, whatever I pull out of here has to look like this. So I see this is a negative, so I'm going to pull out a negative, looks like 6. So I should get 2x minus 3. Okay, these guys look the same, and we can just do 2x minus 3 and x minus 6 is my final answer. I'll write it over here as well. Okay, so there's that one. Moving in 3, 2, and 1. Alright, so this next guy right here, we're going to do the same thing. Negative 2 times 12 is negative 24. Put 5 on the bottom. What two numbers multiply to negative 24 but add to 5? Let me think here. I did most of these before. I didn't do this one yet, or I did, I just don't have it in front of me. So 1 times 24, 2 times 12, no. 3 times 8, that sounds right. 8 and negative 3, there we go. Okay, so we get 12x squared plus 8x minus 3x minus 2. Again, we're going to factor by grouping. Once I've split them in a term, GCF out here, oh, looks like I can take a 4 out, 4x, so we get 3x plus 2. This looks pretty much the same, but these are negative, so I'm going to factor a negative 1 out, and then I get 3x plus 2. They look the same, so we get 3x plus 2 and 4x minus 1. So we'll write that right here, 3x plus 2 and 4x minus 1. Okay. Alright, last but not least, this guy we get 9 times 4, which is 36 on top, and a negative 12. I remember this one, negative 6 and negative 6 will do the trick. So we're going to split that into 9x squared minus 6x plus 4. And we factor by grouping. And here we can pull out a 3x. This will leave me with 3x minus 2. Again, I want this to look the same. It's positive here, that's negative, so I do have to pull out a negative 2, which will give me 3x. Negative 2 out of positive 4 will give me a negative 2. They look the same. So we get 3x minus 2, and then the leftovers happens to also be 3x minus 2, which is kind of cool. And there we go. And last but not least, we get to what's called difference of perfect squares, DOPS. So all I have to do is square root these to get x and 2. And when we do that, we do the addition of them and the subtraction of them, and we're good to go. And same thing here, square root 9x is 3x, and that's going to be 5. So 3x plus 5 and 3x minus 5. Quick way you can check all of your answers to see if they make sense is multiply the two back numbers to see if it's the back number, multiply the two front numbers to see if it's the front number. So we can try it here. 3x and 3x is 9x squared. Negative 2 times negative 2 is a positive 4. 3x times 4x is 12x, and negative 1 times positive 2 is a negative 2. It's not fail-safe because your middle term we didn't check. You could fully FOIL or box method those to see if they're right, but this at least helps you a little bit. Alrighty, that's it. Thank you. Good luck.